Assalamualaikum and a very good morning to Cikgu Nazli. My name is Aileen Dayu binti Abdul Malik. My matric number is B19BE0149. So today I will be presenting the use of satellite remote sensing data in the mapping of global landslide susceptibility. So first, introduction. This paper aims to map landslide susceptibility over most of the globe using a GIS-based weighted linear combination method. In many countries, remote sensing information may be the only possible source available for such studies. Currently, available satellite data may provide useful and accurate information on Earth surface features and dynamic processes involved in landslide occurrence. The use of high-resolution satellite remote sensing products to attempt a global-scale landslide hazard assessment. Information from remotely sensed data is digitally processed and integrated with other ancillary information using a GIS or Geographical Information System. By using GIS-based map overlay technique, it is possible to quantitatively combine several layers of different parameters, which is elevation, slope, and land use, to produce spatial patterns of LS global scale. GIS, DEM, and remote sensing in their study. DEM data can be used to derive topographic factors other than simply elevation, including slopes, aspect, hill shading, slope curvature, slope roughness, slope area, and qualitative classification of landform. Landslide occurrence depend on complex interaction among a large number of factors. In the red box below is the factors, which is geology, geomorphology, soil, land cover, hydrology, human, and also human impact. Remote sensing product can be utilized for deriving various parameters related to landslide controlling factors. Several geospatial data sets were used in this study, and their spatial scales range from 30 meter to 0.25 degree grid sizes. For methodology, first, 6 relevant landslide controlling factors are derived from geospatial remote sensing data and coded into a GIS system. Next, continuous susceptibility value from low to high are assigned to each of the 6 factors. Second, continuous scale of global landslide susceptibility index is derived using GIS weighted linear combination based on each factor's relative significance to the process of landslide occurrence, which is slope is the most important factor. Soil type and soil texture are also primary level parameters, while elevation, land cover types, and drainage density are secondary in importance. Finally, the continuous index map is further classified into 6 susceptibility categories. For the data, the consequent range in susceptibility value is normalized from 0 to 1. The larger the susceptibility value, numerically, the greater the potential to produce landslide. So picture A is the data of DEM, while B is the data of slope. C is the modest land cover classification, while D, landslide susceptibility indices derived from this study. E and F is a landslide susceptibility map from USGS, and all of that is rescaled to 1 kilometer for display purposes. Okay, for the result shows that the hotspots of landslide prone region include the Pacific Rim, the Himalayas, the Southeast Asia, Rocky Mountain, Appalachian Mountains, Alps, and the parts of the Middle East and Africa, India, China, Nepal, Japan, and the USA and the Peru are shown to have landslide prone area. This first cut global landslide susceptibility map forms a starting point to provide a global view of landslide risk and may be used to conjunction with satellite-based precipitation information to potentially detect areas with significant landslide potential due to heavy rainfall. A is a global landslide susceptibility map derived from surface multi-geospatial data. B is a histogram of global landslide susceptibility at continuous numerical values from 0 to 1. C is a histogram of global landslide susceptibility classified into 6 categories. And that's all from me. Thank you, Cik Wan.